Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.
So this is line of symmetry and rotational symmetry. There's line of symmetry, symmetry should be double M, right?
Yep.
I think it's 1M. And rotational symmetry.
No, it's two M's.
Okay, rotational symmetry. Symmetry actually talks about halving. You know, it's about how many number of foldings that lapse. That lap correctly. It must lap correctly, you know. For instance, this question, an arrow is drawn upward, is drawn below. Draw all the lines of symmetry. How many lines of symmetry does it have? A line that can divide it into two equal parts. That's about lines of symmetry. Yes, are you answering? How many lines of symmetry does it have?
One.
Okay, this one has only one line of symmetry because you can only divide it into two equal parts. No more. There's no other line. So it's only one line. One line of symmetry. Okay, so on and on and on. Of course, how many lines does a rectangle have? You can divide it like this, and it must all look the same, or you divide like this. So it's actually two. All right, so two lines. Let's forget about the area. You can just count the boxes. Let me move further to some other things. Okay, first of all, how many lines of symmetry does this polygon have?
One.
It can only be this, so it's also one. Okay. Do they all have a line of symmetry? Which two shapes have a line of symmetry?
B.
B that has this. B and what?
B.
Did you say C or D?
C.
C. Okay, B and C. All right. How will you draw the line of symmetry of C? This, right? Okay, that's the line. All right, let's see. Now, rotational symmetry. You know what rotational symmetry is? If you're going to turn this thing 360 degrees, how many times will it look the same?
4.
In fact, one way you can know that is the number of sides if it's a regular polygon. So it has 4 sides, 1, 2, 3, 4. So it will have 4 order of rotational symmetry. 4 order of rotational symmetry. The number of sides, if it's a regular polygon, will give you the number of order of rotational symmetry. So that's basically how many times, if you're going to be turning the face, like we want to turn this thing 360 degrees, move it round, round, and back again 360 degrees. How many times will it look the same? In four different times, which simply means how many times will it appear the same if turned to or turned by 360 degrees.
Wait, so how many lines of symmetry does a square have? 4, right?
Are you sure?
Okay. Not going that way.
Are you sure? Let's check. 1. If it's a square.
Yeah.
2. Any other one?
Going like sideways.
The diagonals. 3. That's if it's a square. 4. 4 lines of symmetries, but that's different. By the way, how many times it will appear the same when you turn it by 360 degrees? Okay, sorry, that's what I wrote was correct earlier. How many times will it appear the same if turned by 360 degrees? That's for order of symmetry, turned by 360 degrees. This is for order
4.
of symmetry. So that's 4. You can also use the number of sides of the regular polygon to determine that. But line of symmetry is how many times you will divide it and it will be into 2 equal parts. In fact, a square has 4 order of symmetry and also 4 lines of symmetry. Okay, look at this one. How many lines of symmetry? For each of the, write down the number of lines of symmetry and the order of rotational symmetry. Let's go. How many lines of symmetry for this first one? Let me call them A, B, C, and D. Are you sure this one has 4? Be close to your mic.
2.
Okay, let's even check. This is 1. Let's see another one. Let me use a different color. This is 2. Is there any other way you can divide and it will look the same? That is all. Do you know that this is not correct? They don't look the same. Do you know? I hope you know.
Two triangle at the end.
They are not the same. This one you have here is not the same as what you have here. So it's only 2. So only 2 lines of symmetries. How many order of rotational symmetry? How many order of rotational symmetry? Let me see. That will be only 2. How about this trapezium? Line of symmetry, only 1. Rotational symmetry. Are you sure it's only one?
Yeah.
Let's see, this way, this way. This is going to face down. By the time you turn 360 degrees, for real, this trapezium has only one order of rotational symmetry. The reason is you cannot count the one you counted before.
What did I count before?
You know, when you started, it was like this. And if you rotate, there's no rotation of 360 degrees that will get it back to this shape until it comes back to what it was before.
Yeah, that's what I said.
So it has only one order of rotational symmetry. That's correct. Is that what you said earlier?
Yeah.
All right. C. Lines of symmetry. Let's see. Let's see. That's one. Let me use a different color that can come out better. The blue one.
Oh, wrong shape, wrong shape. One.
Let's see. Let me see what you're talking about. Is this not correct? Let's see. You have this, you have this. Let me see. Why do you think this one is wrong? Why do you think the pink one is wrong?
So it's like, I can't afford it, it just doesn't go.
I'm talking about lines of symmetry.
Yeah, I know when you try, if you try to fold that.
Fold it exactly. If you try to fold it, in fact, it is the folding thing that helps to know. A beautiful one. If you try to fold it, it must lap. Very beautiful. Very beautiful. Very, very beautiful observation. If it doesn't lap, when you fold it, it doesn't have, that's not a line of symmetry. Okay, let's see if we try to fold it. Let me just show you something. Do you believe the blue one is a line of symmetry? Okay. Do you believe the purple one? Okay, let me redraw it. Let me use this to divide it into two. If we fold it like this, do you think it will not lap? Are you sure it will not lap? So what do you think? If you fold it on this line that I showed, let me put it in pink, it will lap. Did you hear me?
Yes, sir.
It will actually lap. That is not even the only one. We can still fold it on another line like this. This one will also lap. And yet another line. This one will also lap. And yet another line. This one will also lap. So it actually has how many lines of symmetries?
One.
You just saw what I drew. I'm talking about C. All the lines I drew will lap.
Except for the blue one.
Even the blue one. All the lines will lap. In fact, this is how you will know if it has the number of protrusions will give you the number of lines of symmetry. 1, 2, 3, 4, 5. So it will have 5 lines of symmetries. It has 5. And rotational symmetry will be also 5. Do you know? Okay. I need you to do the second one. Yes, D. What's the answer? Can you still hear me?
Is the lines of symmetry are 2.
1, let's see. 2. Is there no other one?
No.
If we fold it like this, will it lap?
Oh, wait, no. I think there's 4.
But will it lap?
Oh,
You're not sure?
I said it won't lap.
How about like this? Will it lap like this?
I didn't see what you did.
No, the blue, what I just did in blue.
Oh, no.
Okay, let's do a summary. Are you still listening? Okay, for this, only the blue, the green and the red will lap for that rhombus. So only 2 lines of symmetry. All right. Which other ones did we talk about earlier? For this rectangle, only 2 lines of symmetry. For this trapezium, only 1 line of symmetry. The order of rotational symmetry.
4.
Are you sure? So it has 2 order of rotational symmetry. Oh, look at what we said here. This rectangle, how many lines of symmetry does it have?
You said 4.
This rectangle.
Yeah, 4.
No, it doesn't have 4. Let's look at it very well. The blue line we fold, like if you fold the blue line, it will lap. Check it. I think we made a mistake. If you fold the green line, it will lap. Try and fold the purple line. Are you sure it will lap?
Oh, wait, it only has 2.
It has only 2. 2 lines of symmetry. How many will this one have? How many? This number 7. How many order of rotational symmetry? Mm-hmm.
6.
6, of course. You can use the number of faces 1, 2, 3, 4, 5, 6.
Wait, that.
Yes.
Is the number of like. Oh, I don't know.
Go ahead. If you're going to rotate it 360 degrees, how many times will it
Is the
appear?
number of sides that do, like lines of symmetry?
Sometimes they tally. I mean, they are the same. Some other times they are not. It doesn't mean that the lines of symmetry will always be the same as the order of symmetry. It doesn't mean. All right, this has 6 lines of symmetries. If you want to draw it, it's not a big deal because it says on the diagram, draw in all the lines of symmetries. Just use this, 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 this. In fact, you get 6 in all. All right. Let me not mutilate the diagram too much. Let me give you this to try. The ones that have grids. Like this one. Can you read it? Can you see number 10?
Yeah.
It says shading one more grid or one more square to make a pattern with one line of symmetry. Where can we shade? I think this box will be fine. Let me see. Only one line of symmetry. Only one line of symmetry, not 2. Where do you think you can shade? Because if we shade this, how many lines of symmetry will they have? It will have 2 lines of symmetry. If we shade it exactly with the same color, it have 2 lines of symmetry. So where can we shade so that we have only one line of symmetry? Yeah, well, as it is, it already has one line of symmetry, which is this. It already has one line of symmetry, which is this. And we need to shade one more square to make a pattern with one line of symmetry so that we still have one line of symmetry. I think the shading should be here. If we shade here, it will still have one line of symmetry. It will still have one line of symmetry if we shade here. You know, this place we still make it to have one line of symmetry because the line will still cross like this and it can be folded this way. Now what about if they want it to have 2 lines of symmetry? Assuming this question is now changed to 2 lines of symmetry, what will it be? Shade one more square to make a pattern with 2 lines of symmetry. So for it to have 2, we need to shade this other would have shaded this, is it not? So it will now have 2 lines of symmetry, which would have been this green one, you know, and maybe another color, another one, this here. How about this one? Shade one more to make with rotational symmetry of order 2. This wouldn't be difficult. It will be here. Okay. Do you agree? Order 2. By the time you turn it 360 degrees, it will appear like itself only 2 times. How many lines of symmetry does a triangle have? An equilateral triangle have? Hmm? 3, 1. You can fold that way. You can also fold this way. And you can also fold this way. So 3. And it also has 3 order of rotational symmetry if it's an equilateral triangle. All right. I think you can attempt this one. Shading 4 more small squares to make a pattern with rotational symmetry of order 4. If you turn once, you have this. 4 more. Can you try this? Are you still there?
Yeah.
Can you try this? Let me see. This. Let me see this. This. Think about it. Will it produce order of rotational symmetry 4? Yes.
Yes.
Yeah. Because we need 4 more shadings so that we produce that. All right. Let's see some other ones. Let me see any other one on the grid line. What's this one talking about? The diagram shows a net of solid shape. What's the name of the solid? Wait, what's the name of the solid that it will form when you fold it? What's the name of the solid you form when you fold it? Are you still there?
What did you say?
What's the name of the solid this will form when you fold it? It will form a cube. All right. The net has one line of symmetry. Draw the line of symmetry on the diagram. That's for the net. What's the line of symmetry for this net? I think it's only this, right? Then it says add some more squares to the diagram below so that it has rotational symmetry of order 4. so that we have rotational symmetry of order 4.
Any square are we allowed?
4. Okay, well, as many as you can. Add some more squares to the diagram below so it has rotational symmetry of order 4. As many as you can add. Let's add this and see. Add this and add this. It will have 4. 3, we just need 3 to make it have 4. Do you understand? Do you agree? Do you agree with me?
Yeah.
With this additional 3 more squares, 1, 2, 3, it will have 4 order of rotational symmetry. All right. Okay, no, it's here they wanted us to add it. Let me clean it here. Let me leave this one we drew earlier on it. Only one line of symmetry. So this is where we are supposed to add it. Another one. Another one. Another one. All right, I think that makes sense. It should be. Look at this one. Can you get the? It says complete the diagram above so that it has rotational symmetry order 2 about center center A. Can you attempt that? And this other one too. This one. This one. You know. Which one can you attempt? Look at this one. Shading the fewest possible squares to make a pattern with 2 lines of symmetry. Fewest possible. 2 lines of symmetry. Can you think about that? Only 2 lines of symmetry.
No, wait. Let me think about them.
Yeah. Look at the numbers I wrote and tell me where you put the squares so I can shade it and check. Where do you put the squares? Box 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Tell me where.
Okay, so I put 1 square in number 5.
Number 5. Okay. Let me shade it.
There's a square in number 16.
16. Let me shade it.
There's a square in number 6.
Number 6. Let me shade it.
Then there's a square in number 13.
Number 13. Let me shade it. Okay. So 2 lines of symmetry. You did this. Am I right?
Yeah.
And also this. That's correct. By the way, what's the name of this shape? Shape A and shape B.
Because
No, B. A is what? A is not a rhombus. All the sides are not equal. A is a parallelogram. How many lines of symmetry does it even have? Does it have a line of symmetry? Can you try folding? Does it have a line of symmetry? In fact, to know the line of symmetry, when you fold it along that line, it must lap. For instance, it's not so you need to actually visualize that. If you fold this one along this pink line, it will lap. You know, If you also fold it along the red line, it will lap. So for this parallelogram, where can you fold it and it will lap? If you try folding it like this, will it lap? No, it won't lap. Oh. It won't lap. Even this one will not lap. This one too will not lap. In fact, a parallelogram has no line of symmetry. Does it surprise you? Did you hear that? A parallelogram has no line of symmetry.
I feel like cause it's square, but like
What did you say?
I feel like it's cause it's a rectangle.
Oh no, if it's a rectangle, it has two lines of symmetry. But the parallelogram has... Pardon?
Don't the rhombus lines of symmetry?
A rhombus has lines of symmetry. We showed that now earlier. In fact, a rhombus has how many? We showed it earlier. Where is it? A rhombus has two. This is a rhombus. Well, a rhombus is a special parallelogram where all the sides are equal. A rhombus has two lines of symmetry. But other parallelograms that are not, that don't have all their sides equal cannot fold. So zero line of symmetry. Zero line of symmetry. What is this one below it? What's the name of this shape B? It's just a sketch, so what's the name of shape B? This is a kite now, isn't it? How many lines of symmetry? There's only one way you can fold it and it will lap. So one line of symmetry. You see why I told you that it may have a line of symmetry, but it may not have, it may not be the same as the order of rotational symmetry. How many order of rotational symmetry does this kite have?
One.
How about the parallelogram? Before I verify what you're saying. Let me show you. All right, you said the parallelogram has how many order of rotational symmetry? Two. Please, you need to speak up. Oh. Two order, that's correct. If you rotate it by 360 degrees, it will look the same way. Two order of rotational symmetry. And can you see why it said it doesn't mean that number of lines of symmetry will always be number of order of rotational symmetry? Can you see that? Can you now confirm what I just told you? I told you earlier. Please, I need you to speak up. Can you hear me?
What did you tell me earlier?
I told you that it does not always mean that the number of lines of symmetry will be the same as the number of order of rotational symmetry. For instance, this parallelogram has how many order of rotational symmetry? I mean order of rotational symmetry. Speak up.
Two.
Two. And how many lines of symmetry? It has two order of rotational symmetry, but zero line of symmetry, because there's no way you can fold it and it will look the same way. It won't lap. I mean, if you fold it, the two ends will not lap. If you try it, you will see. You may look, but no, it will not, because this edge you have here will not lap with this edge when you fold it. Neither will this lap with this. Okay, look at this kite. This kite has one line of symmetry. How many order of rotational symmetry does it have?
One.
It also have one line of symmetry and one order of rotational symmetry. Sometimes it may be the same, some other time it may not always be. So, and one order of rotational symmetry, one order of rotational symmetry. Can something have a zero order of rotational symmetry?
No.
Beautiful. So a kite has one line of symmetry and one order of rotational symmetry. Something cannot have a zero order of rotational symmetry. At least it can have one. At the time you rotate it 360 times, 360 degree turn, at least it will look the same once. You're not going to count the 360th one, because it will mean you are counting it twice. So sometimes the best definition of, let's quickly run this a summary so that you can get the difference. So a simple summary. Order of symmetry is how many times it will appear the same if turned by 360 degrees. But please, I need to add that you should not include the 360th degree turn, because we've counted it before. So can I say excluding the 360 degree turn, so that you don't count twice? Excluding the 360 degree angle. Do you understand what I mean? Because if you're going to add it, it means you'll be adding it 2 times. So excluding the 360 degree angle. So how many times how many times it will appear the same if turned by 360 degrees? Let me adjust this. It will appear the same. It will appear the same if turned by 360 degrees, but excludes the 360 degree angle. That's for order of symmetry. Now, line of symmetry, how many times it will be folded so that the edge, it will lap. Line of symmetry is about how many number of foldings that laps. That lap correctly. It must lap correctly, All right. For instance, we already said this has 4 lines of symmetry and also 4 order of rotational symmetry because it's a square. You can fold it in 4 different places and it will lap. You also rotate it 4 times, 360 degrees, it will appear the same in 4 different places. Let's see, this one can lap like this and lap like this. 2 lines of symmetry and 2 order of rotational symmetry. This trapezium, 1, 2, 3, 4, has 1 line of... A trapezoid has no line of symmetry. A trapezoid. Any trapezium that does not have a line of symmetry is a trapezoid. Something like this. I hope you know this one does not have a line of symmetry. Not all trapeziums have a line of symmetry. This one does not have. So we call this trapezoid if it does not have, because there's no way you can divide it into 2 equal parts. This one is 0. 0 line of symmetry. That is for this one. but this one has 1. So how many? Of course, this one we have only 1 order of rotational symmetry, and so on. How many did I say a rectangle has? This cannot, it can be folded along this line and it will lap. A rectangle has only 2 lines of symmetry. You know. Okay. I think we are good on this.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to 2 main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.